Hello, my name is Aneta Wiśniewska and I am a postdoc at the Leibniz Institute for Astrophysics in Potsdam, Germany. And this is also my first time in Vienna, so I'm happy to be here. And today I will be talking about the frequency distribution of solar oscillation inside the coronal hole. So I want to tell you about the link about the solar magnetic field and the oscillation. Then I will jump into the coronal holes inside the solar atmosphere, tell a little bit about the multi-wavelength morphology of coronal hole, and I will show you our data from Solar Dynamics Observatory and time normalization, and I will focus then on the magnetic field extrapolation and the Fourier power spectrum and wavelet analysis. Okay, so the helioseismology links directly the oscillations and magnetic field studies. So helioseismology studied the solar interior using observations of waves on the sun's surface, and it has done much to improve our understanding of the interior of the sun by providing a detailed map of the sun's structure and internal rotation. So this has greatly influenced the theories of the solar magnetic dynamo, because as you can see, on this little figure, then the magnetic field has actually the roots inside the sun. So this what we are observing, let's say in the EUV band of AIA is only this what we are observing outside its atmosphere. So recent developments include new local techniques and the studies of the flows in emerging activities and under sunspots give a lot of information which can improve the investigation of magnetic dynamo. And also all manifestations of solar magnetic activity from spectral irradiance variations to solar storms and geomagnetic disturbances are caused by magnetic fields generated through a dynamo mechanism operating in the convection zone of the sun. So because the oscillation and magnetic field are gained with each other, this is important, while magnetic features investigation to look also at the oscillations and the accompanying waves and their physical parameters. And here you can see also the zonal flows of the plasma inside the solar atmosphere and the interior. Okay, so we know that the solar corona is highly magnetized, but overall the solar atmosphere is highly inhomogeneous. So the plasma beta is very important parameter which showing us that actually magnetic field dominates the thermodynamical properties of plasma motions inside the solar corona. So the coronal holes, if we look at the average intensity for many lights at the SDO AIA data, looking differently at the many levels of the solar atmosphere. So I plotted for you this kind of cast through the different solar layers, just to show that it appears differently at the bottom, so in the photosphere and the corona. Okay, so what is coronal hole? It was already much about it here, but coronal hole is a temporary and large region of relatively cool, less dense plasma in the solar corona. So, and the very weak magnetic field strength, which is about 1 to 7 Gauss in these areas. And coronal holes are characterized by open magnetic field lines, as we know already. So also the most important is that the strongest solar wind originates exactly from the area of solar coronal holes. So, oh yes, now the video is running. So our target coronal hole is in the middle of the disk center. And you can see the potential field source surface model for this region. So as you can see on this video, the magnetic field is changing with the time. So we did also magnetic field extrapolation for this region, and this is done actually at the solar surface, and this is also done based on the PFSS model. So what kind of oscillations do we have in a corona? So basically these are propagating transverse waves. And if you look at the SDO AI filtergrams, in the middle panel you have a zoom into the coronal loop. And if you are looking at the running difference image, then you can observe some motion of the propagating waves. So in the coronal loop, the magnetic field is frozen into the plasma, so galvanic motions is observed almost at each loop. And the amplitude of such a waves are 52, actually these are the velocities for 50 to 20 kilometers per second, and the periods are 100 up to 500 seconds with the lifetimes of 50 to 500 seconds. So the energy flux of the quiet sun and coronal holes is about 100 to 200 watts per square meter. And here you can, I prepared for you some cartoons of the MHD waves, which are propagating inside the coronal loops. So you have here the sausage mode and the king modes, and also like a different solution for it. So when we have a coronal loop, basically we can say that the transverse displacement propagating upward, but this is kind of three-dimensional oscillation, so it oscillates in every direction. So depending on which line of sight we will be observing this kind of features, then different results we will get. However, if we are observing, let's say, from the top side, so our line of sight is perpendicular to the solar surface, the most power would be concentrated at the top of this loop. Okay, and I think that, yeah, okay. Okay, so oscillation inside the solar coronal hole. So we wanted to analyze oscillations, and for that we prepared some special normalized data to kind of simulate the velocities inside the solar coronal holes. And we took filtergrams at 193 angstrom. And as you can see here, the most concentration of the power is at the frequency of 6 to 7 millihertz, and this is the power spectral distribution of the intensity data, actually from this normalized one. So to do it more accurate, we wanted to kind of concentrate on some very, very small targets. So one is outside and the second one is inside. And indeed, if we prepared some time plots of intensities, then we observe some oscillation. But to do it more accurate, we calculated the wavelet spectra. So at the wavelet, we found most dominated oscillations with a period of 8 to 11 minutes inside the coronal hole, which is similar reported by McIntosh et al. 2011. And outside the coronal hole and surrounding area, this period is about 7 minutes, but most significant are short periods of 1 to 1.5 minutes. And thank you very much for your attention.
Thank you.
Here are the references.
We have time for one short question. Yes, Stefan?
Thank you for the nice talk. You said the oscillations are different inside the coronal and outside. Could that be a way to determine the coronal boundary very well?
Yeah, actually, the goal is to kind of investigate the structure at the different levels of the solar atmosphere. So we want to find the roots, and maybe it can be somehow related to the oscillations. For now, because this talk is limited in time, so I cannot show you all the results. But yeah, so we would like to investigate it further.
Well, if you have further questions, you can catch up with Aneta.
Yep.